We're going to finish off with Newton's three laws by talking about Newton's third law, the law of action and reaction. This law simply states that every action has an equal and opposite reaction. Now this is one of the most simple laws and the easiest one to answer on the MCAT, but you have to be very careful about it. I would say 80% of the students I've taught have a very common misconception about this that I've had to clear up. So make sure that you're not one of them, and if you are, make sure that you change your habits right now. Okay? So that misconception is that oftentimes when we're talking about Newton's three laws, we talk about, for example, a person standing on the ground. And this person has a downward force of gravity, mg, right? And there's an opposite force that is opposing it, that is the normal force. Now these two forces are equal, they are opposite, and that's the reason why our little person here is not accelerating. But these two forces are not Newton's third law pairs. Make sure you are very comfortable with that idea. Remember that Newton's third law pairs are equal in opposite reactions. Although these may be equal in value, they are not equal forces. One is a normal force, one is a gravitational force. That should be a big hint to you when solving these Newton's third law problems. They have to be of the same type of force. So for example, if we're dealing with this gravitational force, the equal and opposite pair to that is another gravitational force. So there are actually two sets of Newton's third law pairs in this case. So let's go ahead and start off by talking about the gravitational pair. So in this case, what we've diagrammed out so far is the gravitational force of the Earth on our man. And the Newton's third law pair for that force is going to be the man's gravitational force on the Earth. And these two forces are equal to each other. I'm going to write acceleration here rather than gravity because gravity is illustrating the acceleration of the man because of the force of gravity. Okay? Now the reason why I say that is because a lot of people get confused about this. They understand that according to Newton's third law that the forces should be equal, but it doesn't seem to make a lot of sense conceptually. And usually the reason why is because you're thinking that the force of the Earth seems to be pulling harder on you than you are pulling on the Earth. But it's actually not true. You're pulling equally on each other. So we can see here, the difference is in the acceleration. When you jump out of a plane, for example, you consider yourself as falling towards Earth because you are accelerating towards the Earth a lot more than the Earth is accelerating towards you. But that is not because the force of the Earth on you is stronger. It's simply because the mass of the Earth is a lot greater than your mass. So here we can apply what we've learned from Newton's first and second laws. We can see that even if the force is equal, if the force is acting on a much smaller mass, you in this case, then your acceleration is going to be a lot greater, simply because you have a much smaller inertia or ability to resist a change in motion than the Earth does. Now the other Newton's third law pair here is obviously the normal force. We've got the normal force of the Earth on us, but in addition to that, we've got our normal force on the Earth pushing back. And these two forces are also equal and opposite in the same way. So keep that in mind. Do not make the common mistake of associating two different forces that just happen to be equal in a certain scenario and confuse them for the Newton's third law pair, because that is never true.